So hello everyone. Blockchains, catchy word, eh? So my name is John Kaldis, Athens Information Technology. We're going to be talking about edge computing and blockchains, especially in industrial automation. This is a huge presentation, so I'm going to have to skip a few slides, unfortunately. So the project Far Edge is Factory Automation Edge Computing Operating System Reference Implementation, and what it actually does, we do flexible, decentralized factory automation, and you can see our partners here. But if I were to be asked by someone, okay, what's important about this project? It's three things. We gathered the leaders, the global leaders around the world with standardization and said, okay, what have they told us about industrial IoT as reference architectures? Let's gather them all together, put them in the bucket, and see if we can create a reference architecture that encompasses all of their ideas together. The second, as we will see, is that we have created a tier in the architecture called ledger tier, in which we run blockchain for non-monetary reasons, but for coordination, for synchronization, and for security. And the third is that we have taken a protocol called NGAC, Next Generation Access Control, which, to our knowledge, is the first implementation of this protocol for industrial IoT. So first, the reference architecture. We just looked at the leaders. RAMI, Reference Architecture Model for Industry FIA, Industrial IIRA, and OpenFog. And we tried to create a synthesis of their best practices with a common context, a common vocabulary, and a common repository of patterns. From Industrial Internet Consortium, you are very well, you know this, I suppose. We are very interested in their three tiers pattern, in which we have added the ledger and their functional viewpoint. From RAMI, Industry FIA, we are particularly interested in their layers and the encapsulation of the smart objects. And from OpenFog, which is very similar to IIC and also has big players like IBM, Microsoft, Intel, and all the big guys. We like the cross-cutting functions and a few other issues that we will see. And this, we could be talking for hours about this reference architecture, but in simple terms, we perform automation, analytics, and simulation vertically. We perform cross-cutting functions, and we have the field that has edge servers, that has a ledger of blockchain that posts to the cloud. I'll skip a few slides not to tire you. Yes, we are doing automation and Arrowhead and all of that. We are doing analytics and focused BI. We are doing simulation, testing what-if scenarios. We have the cross-cutting functions of this reference architecture. By the way, I forgot to mention that we are very, very interested, because I had a fast look at Productive 4, and we will be very interested in your work package 6 called standardization. We will be following this very closely. And as a structural viewpoint, like I said again, field, edge, ledger, and tier. I will not tire you, but the differences between a scope and a tier, there's bibliography for all of that. And you end up with having components, i.e. self-consistent software packages. Each of them, we are strict, has to be in only one functional domain, one cross-cutting function, and only one tier. And some of them being very important, they are endpoints of integration, and they can be a standard technical specification that anyone can access. We call those enablers. I will not tire you anymore. If you see dark blue, it's enabler. If you see light blue, it's components. You will have access to this presentation, I suppose, and we will be open to communication if you need more details. These are a few of the protocols that we are using, and I will not tire you with technicalities. So the second thing, blockchain, everybody loves that. We have put an abstraction which simply says that if you have lots of edge servers together and they want to communicate with each other and reach unanimous agreement that a new record must be created, we believe that this is where the full potential of the edge computing is unleashed for one reason. You do not send non-important data to the cloud. Plus you have speed. Okay, there's a distributed ledger with smart contracts. It's a truly distributed process, and the way it's built, it's open and has no constraints of deployment irrespective of any technical platform. We have chosen the Hyperledger fabric. Why? First, because it's permissioned. It's not public, and companies are very sensitive with their privacy. Second, because it has much faster performance. And like I said, what do you do with a Hyperledger? We do distributed process synchronization. Okay, this is a slide by IBM. There's roles, there's validators. You will see that later on. The point is you reach consensus for every record transaction. So this ledger is replicated in all PNs. It stores and maintains the data and the shared state of the distributed processes, of course, there's cryptography. And every modification in every smart object or in every edge server must be system-wide through unanimous consensus. Obviously, you need majority. Yes, we do have smart contracts. We have decentralized coordination. We have found out through some tests that it is ideal for clients that have frequent reads and infrequent writes. And that's why we believe only highly valuable data should be persisted on the ledger tier. That's just a shape of the same things. Let's see number 3. So there's this thing called Next Generation Access Control. It's a reference implementation, known as the policy machine. It's publicly available. To our knowledge, it's the first time that someone uses it in industrial Internet of Things. The reason we chose this is that one of the partners of our project is Open Group. And Open Group is a member of the Industrial Internet Consortium. And the Industrial Internet Consortium has created the Industrial Internet Security Framework, IISF. And how do we build IISF in our project? To be consistent with the leaders. So in Far Edge, we do IISF security through endpoint protection, communication and connectivity protection, security monitoring, security configuration and management, and data protection. These are the 3 things that we do. If you were to ask me what's different in this project, these are the 3 things. We have some use cases like everybody else. One is Volvo, the other is Whirlpool, and the third is Smart Factory, which I believe is a partner in Productive 4, I'm not sure. So Volvo has trucks, and they have wheels, and they need alignment. And the tools need specific configuration, rotation angle and torque. But they make mistakes, and they want to deploy a large number of WAS equipment around the world, service shops. And they want to have automated configuration and save time through training. Also, these edge servers talk with each other through blockchain. I will not tire you with details. The other application is Whirlpool. They have a conveyor that dispatches products as they come to 3 conveyors and then to trucks through forklifts. But unfortunately, for the time being, they dispatch them according to the production plan and not according to how much weight a particular truck can carry, the forklift, the conveyor belt, and they need to have very fast adaptation according to what comes out of the production. So we are implementing a sorting algorithm for them. This is just a schematic of what we're doing. You can see the distributed ledger tier. But as you know, you cannot test all possible scenarios for such a big reference architecture in just 2 plants. So we create particular difficult scenarios that we have smart factory to test them, to deploy them. That sums it up. If you're interested, there's further info. What I would really like you all to do, since Productive 4 is such a huge project, we have an ecosystem called Edge for Industry. We would be very honored if you took 2 minutes and registered in this. I want to thank you all for your time.